YouTube channel, and let's discuss about the hybridization and also the valence bond theory VBT part 2. So in this part 2, we are going to discuss about the mode of orbital overlap and also the types of covalent bonds. So here, the diagram here show you the single bond. It is actually a sigma bond, okay, where we have the overlapping side to side, okay, sideway overlapping between carbon and also another carbon here. Okay, so this is where we have the C2H6, okay, alright. So this overlapping from side to side will form what we call as sigma bond. Okay, this is the sigma bond with sp3 hybridization. Okay, so sp3 hybridization will give us the tetrahedral geometry. Okay, so here we have two types of bonds. Okay, first one is the sigma bond and the second one is the pi bond. Alright, so how this sigma bond forms? Okay, it is actually overlapping of end-to-end orbitals, okay, in order to form the sigma bond. In this case, we have the C2H6, okay, alright. So the overlapping of the end, okay, and of this P, alright, in the carbon, alright, and also another end of this P, right? So this is what happened, okay, end to end of orbitals, okay, overlap to form a sigma bond. Okay, so these two carbon here are having the tetrahedral geometry. Okay, another one here, the formation of the pi bond. This is happen when this what we call p orbital overlap side to side. Okay, so this here, when you look at this structure, we have the one sigma bond and also one pi. Right, so this is the formation of the end-to-end orbital in order to form the sigma. While, okay, the P here, okay, the P here at the PY, okay, this is between PX and also PX, and this is between the PY and also PY, side to side, okay, overlapping of this PY and also PY will form the pi bond, okay, the pi bond, right? So this is what happened in this structure where we have the formation of pi and also sigma bonds. So here, alright, this is also the same compound where we have the overlapping end-to-end of orbital, right, end-to-end orbital overlapping of end-to-end orbitals, okay, it will form a sigma bond, while for the side to side, okay, side to side overlapping will form pi bond. Okay, so this is the bonding that form in the compound, okay, the presence of 5 sigma bond and also 1 pi bond. Alright, so for the 1 pi bond, okay, how, if we look at this, it looks like we have 2 pi bond, but this one, okay, a pair of side to side overlapping will give us 1 pi bond. Okay, so this is overlapping a pair, 1 pair will give us 1 pi bond. Alright, right, so this is another diagram also with the same compound here, and here we go to the sp hybridization of a carbon atom. So carbon actually can form or can have the sp hybridization if this carbon has C triple bond C. Okay, right, so for the carbon here, the ground state here is 2s2 and 2p2. Okay, carbon we have 6 here, 1s2, 2s2, 2p2. So 2s2 and 2p2 will be the valence electron for the carbon. Okay, so what happened here? If we have C triple bond C, okay, we are going to have 2 pi bond and 1 sigma bond. Okay, alright. So what happened? One electron from the 2s excite to the higher orbital, which is a 2p, and then alright, so what happened? It will, okay, let me show you. Alright, here, this is the 2s, this is the 2p. We have full, and then here, okay, so this one orbital excite to higher energy. Okay, excite to higher energy, and we have 1, 2, 3, 4, 1, 2, 3, 4. Okay, so all of these will be having one electron. Okay, this is where we have the S and also P. Alright, while for these two, okay, will give us the pi bond. Okay, how many? 2 pi bonds. This combination between S and also P will give us a linear geometry, alright, with 1 sigma bond and 2 pi bond if we have C triple bond C. So these are examples, okay, what happened, okay, if we have the C triple bond C. Okay, here we have the, okay, this is the formation of the sigma, while for this one is the formation of one pair of these overlapping side to side from PZ to PZ. Here will give us 1 pi bond, while for the overlapping of the side to side between the 2py and 2py will give us another 1 pi bond. Okay, so in C triple bond C we have a 2 pi bond and 1 sigma bond. Okay, right. So let's recap. This is where we have single bond, where we have 1 sigma bond, double bond, 1 sigma bond, and 1 pi bond, and triple bond we have 1 sigma bond with 2 pi bonds. Okay, the question here: how many pi and sigma bonds are in acetic acid molecule? Okay, so this is the structure of acetic acid. So we are going to have here the sigma bond is 6, where 1, 2, 3, 4, 5, and also 6. Okay, right. And then other than that, we have 6 plus 1, where here, okay, and then we have a pi bond here. Okay, so 7 sigma bond and 1 pi bond. Okay, alright. And then guys, this is the sample problem on describing the bond in molecules. Okay, so you need to be able to determine the or to draw the Lewis structure and also the molecular geometry. Okay, then you can predict the hybridization. Okay, so here the first one we have sp3 hybridization. This is also sp3, while this carbon we have the sp2 hybridization. Okay, so this is what happened if we expand the structure. And then this is how we need to show how we can show the presence or the formation of the pi bond. And then this is the question 2. Okay, please do this question. I will discuss later in our virtual class, and also this question. And last but not least, okay, please answer all these 3 questions. So that's all for today, and that's all for this part 2. I hope you guys enjoy the video. So please don't forget to like, comment, and also subscribe to my YouTube channel. And have a nice day, guys. Thank you. Bye.